To those that are new, welcome. To those that are coming back, welcome back to my YouTube channel. Today we are going to be talking about algebra. This topic is needed for grade 8, 9, 10, 11 and 12. Now, we are going to go in the basics. When we speak of algebra, we are talking about combining variables or rather letters with numbers. Now, in your lower grades, you were taught about something like this. 3 plus a certain number must give me 10. Then you were asked to fill in what number fits there. You would say 7. Now, however, because we are maturing mathematically, because we are maturing in mathematics, we now get rid of the squares and the box and the hearts and the spaces, and then we replace them with variables. It could be x, could be y, could be m, could be any letter. So we cannot just continue for the rest of our lives just using boxes and all that. Now, in algebra, we have what we call expressions, and then we have equations. So now we need to understand the difference between equations and expressions. An expression is something like that, 3x minus 4. There is no equal sign involved. However, an equation is something like that, 3x minus 4 equal to 8. So that means there is a solution. You are able to solve for the value of x here. So this is an equation. Just remind yourself, equation, equal sign involved. However, an expression, no equal sign involved. Here you can only simplify an expression or perhaps factorize it, but you cannot solve an expression. However, an equation needs to be solved because there's an equal sign involved. We have different types of equations. We have linear equations, we have quadratic equations, we have cubic equations. Now, to understand those, a linear equation is when your variable is powered, the highest power is 1. This is a good example of a linear equation. For a quadratic equation, your variable is powered to 2. So we have something like that. Now, a cubic equation, however, is something like that, meaning the power is cubed, the highest power is 3. This is how a quadratic equation looks like, and this is how a cubic equation should look like. Please take note, for linear equations, we can have one with one unknown, which is something like this, or we can have 2 with 2 unknowns. However, you will need 2 equations to solve for 2 unknowns, and we are going to learn how when we get to go in equations, like to discuss equations in detail. Getting back to today's lesson, we are going to start with understanding expressions and working with expressions. So we are going to go in details and try to understand expressions and then see what is expected of us to do when we are either adding or subtracting or multiplying and dividing. That is now for expressions, because we are not solving anything. We can only simplify the expression. So we are going to look at a few examples. When we are simplifying expressions, or rather to understand expressions better, we need to take note of the fact that an expression is made up of what we call terms. Now, these terms in an expression, we need to also be able to tell how do we identify terms in an expression. Terms in an expression are always separated by a plus or a minus, and they are always joined by either multiplication, division, brackets, fractions, roots. We should be able to tell how many terms do I have in this expression. Take note, terms are separated by a plus or minus. However, they are joined by brackets, multiplication, division, fractions, and roots. I'm going to give a few examples here. Now that you know how to identify terms, or rather how to count terms in an expression, you want to pause and see Ask yourself how many terms are in this expression before you can continue and see if my answer is the same as yours. Ask yourself, how many terms do I have in this expression? How many terms do I have here? Then you can kind of continue the video. To continue, this is going to be one term. Yes, we were told terms are separated by a plus or minus, so we can see on the numerator we have a minus, so it's supposed the 3x is separated from y by a minus. However, everything is joined together with a 4 by a division, because we know division and fraction, so it's joined together when we made it a fraction. Therefore, here we only have one term. Then in B, we see that 3 and x are joined together because we know 3x means 3 times x. However, that is separated from y by a subtraction, so making it 2 terms. Then we go to C. We see that, okay, we have 3x minus 4 supposed to be 2 terms. However, it's joined to 4 with brackets, and then it made it 1 term. The last one, we have 3 terms. This is 1 because 3 is joined with x. However, this is separated from this one by a subtraction, as well as separated from this one by a subtraction. Therefore, we have 3 terms. We are going to now look at addition and subtraction in algebraic expressions. However, before we get to look at a few examples, we need to take note of the following: that only like terms can be added or subtracted in algebra. Another thing is that when we see that, we're not talking about addition and subtraction. When we see that we have the same signs, what we do is we add the numbers, keep the sign. So it means if all the numbers were positive, we are going to add them and then make the answer will be positive. However, with the numbers, or both numbers were negative, meaning they are still the same signs, so we are going to still add the numbers and keep the sign, which is going to be a negative in that case. If I had negative 7 minus 3, I know that I look at the sign. The sign in front of the term is the sign for that term. Now, when negative 7 minus 3, I have the same sign, so I was taught that I should add the numbers, meaning adding 7 plus 3 is going to give me 10. However, I was also instructed to keep the sign. I should be able to do this. Remember, we are accommodating the grade 8s, and grade 8s and 9s do not use a calculator in one of their papers, so you will need to make sure that you know how to do this. Then we go to different signs. Different signs, if I see that my signs are different, I should subtract the numbers. Doesn't matter which one comes first. You subtract the numbers, meaning you find the difference, and then you take the sign in front of the bigger number. Let's say we have a negative 7 plus 3. The instruction says I should subtract the numbers, meaning I'm going to say 7 minus 3. That gives me 4. But then I was instructed that I should take the sign of the bigger number. And between 3 and 7, 7 is bigger. So I'm going to take the sign of 7. So my answer is going to be negative. Now, it's not always that you need to just be depending on your calculator. You need to be able to do this without a calculator. Now, we are going to look at some examples of addition and subtraction. But before we go to the examples, we need to understand what do they mean by only like terms can be added or subtracted. Like terms must have the same variable. Remember, in algebra, if we have a to the power b, this is called the base, and this is called the index. You can say the power or the exponent. Now, when we are talking about like terms, we need to be able to look at our bases, and the bases should be the same with the same power. Then I'm going to say that every base that is the same must have the same power in the term for me to call it like term. The coefficients, they can be different. For example, if I have 3x squared y, a like term to that can be a negative 2, x squared y, maybe 6y x squared. All those are like terms because they should be, for me to call it a like term to this term, it should have an x squared y. No other variable, and the x should be power to 2, the y should be power to 1, for me to refer to it as a like term to this. However, if you look at this, the last term that I just gave you, 6y x squared, it's still the same thing as that. Because remember, if I can decide to rearrange this and make it look like the other one, 6, then I put the x squared first before the y, because it's supposed to be that way anyway, because it's supposed to be in alphabetical order. So it will be 6x squared y, which means the same variable should have exactly the same power for me to refer to it as a like term. Unlike terms are, for example, if I was given maybe 3x squared y, then I say this is -2, this is x squared, but then y squared. Or perhaps it's 3, then this is x squared y, but then there's a z there. Then I know all this x is power to 2, but however y is power to 1. And in this case, x is still power to 2, however y is power to 2, which makes it different from that one. And I said all the variables should have the same power. Actually, I should have the same thing. The moment I see that I don't have the same thing, then I should know. I'm talking about now in terms of variables, because the coefficients can differ, the number can be different. However, the variables should be the same with exactly the same power. So that's how, and we are told that in addition, only like terms can be added or subtracted. Meaning if I put a plus there, then I say that you cannot do anything to that. The only thing you can do to this expression is perhaps factorize it. You cannot add this to that. It's like saying apples plus bananas is equal to 5 apples. But what happened to the bananas? You cannot count them as one thing. Let me give you an example. Now, the question says simplify. So what I'm going to do is, what it means is that I should try to do whatever I can do to this expression until there's nothing I can do anymore. First thing is to identify your like terms, meaning you want to look at which one has exactly the same variables. So we are going to do that. Then we see that, okay, these a's 4a squared, we now look for its like term, meaning we are looking for any coefficient with exactly a squared. So we want that, only a squared, and we see that here. However, remember that the sign in front of the term is the sign for that term. So if you decide now to rearrange, because it's personal choice, some people decide to rewrite this, put the like terms next to each other, which is perfectly fine, making it easier for them. So what I mean is that they do that and then they bring the like term here. However, don't just come say minus, and the minus you're writing is not this minus, it's the minus that is with 3a squared, because it's a like term to that one. So you come and write it like that. Yeah? So please make sure that you are considering the sign in front of the term you are moving. Then we continue to negative 2ab. Then we see, okay, now this term, where do we see its like term? We see it here. However, remember to take the sign with. We already wrote out negative 2ab. Now we need to bring down the negative 4ab. Now some people get confused when they write this plus. However, that is this sign. So you cannot come and make it part of that. So please, when you bring this from that side, take it with its sign. The sign is part of it. So we say minus 4ab. So that is sorted. Then we see that, okay, we have 3a here. So it's plus 3a plus 10. Everything is now part of our new expression, rearranged expression. What we are going to do is we are going to work on the like terms now, because only like terms can be added or subtracted. So we are going to do that. Remember, this sign is for that one, so let's not include it yet. It's not even making sense if we include it. Then we know that, okay, that means this one shouldn't leave the sign out, should be worked out with that. The others are going to be alone because they don't have a like term. So now to continue this, we see that, okay, 4a squared minus 3a squared. It's just like saying 4 minus 3, because I have a squared is the common term. Is what makes it a like term, right? It's like saying 4 apples minus 3 apples. How many apples am I left with? I'm going to be left with 1 apple. It's still an apple, so please don't touch the power. I must still just bring it as it is. So, which we don't write as 1 a squared, we just write a squared. These you just work out like normal numbers. Remember, we say different signs because the 4 is positive, the 3 is negative. Subtract the numbers, take the sign in front of the bigger number. Subtracting 3 from 4, we get 1. Taking the sign in front of the bigger number is positive 1. That is why we have a squared. Then we move on to the next one. Before you write the sign, make sure you know what this results to. So I have negative, it's like negative 2 minus 4. I know it's AB, so I'm still going to have AB there. However, I want to have the right number, the right coefficient. So I'm going to say, I see same signs, right? What did we say about the same sign? We were told that we add the numbers. So we are going to say, because the same sign, add the numbers, 2 plus 4 is 6. Keep the sign. So it's going to be minus that. Hope you are able to see that. Then we go to the last one. The last one, so we're just going to bring down as it is. And we are done. Remember, the question said simplify. So it means you are doing whatever you can do until the point where you can't do anything anymore. So I have a squared, ab, a, 10. I can't add any of those terms because they are not like terms. So we are done. B, remember, pause the video, try to simplify it yourself. Then you come and continue it to see if you are correct. So now we group the like terms. Now we're not going to rewrite them and rearrange them. We're just going to take note of our like terms. So we can use any way. Circle them perhaps. We have 10x squared and it's a like term to negative 17x squared. So what we basically have there is we have 10 minus 17. And those are different signs. And what were we told? We were told that different signs, we subtract the numbers. So we are going to say 17 minus 10, subtracting the numbers. And 17 minus 10 gives me 7. And I take the sign in front of the bigger number, which is negative. So it's not negative 7. However, it was x squared. I should not just write negative 7, because then I change the term if I only write negative 7 without the x squared. See that these two are not like terms, because x here is power 1, here x is power 2. That is already telling me not like terms, because even if y is the same power, the fact that x is not makes them unlike terms. So we are just going to bring down the unlike terms because we cannot add apples to bananas and count them as one thing. And it means we are done because there's nothing you can do there. They are all unlike terms. And that is what we do with addition and subtraction. Remember, same signs, add the numbers, keep the sign. Different signs, subtract the numbers, and take the sign in front of the bigger number. Thank you so much for watching. Don't forget to subscribe, share the video with those that may need it. Until next time, much love.